Hey guys, welcome to your Chapter 10 practice test. Make sure that you get practice beyond this test, not just on this one, before your test next class period. First thing, and this doesn't look like your practice test, but these are the problems from your practice test, is solving the equation using the square root property. Something to note is that the only thing we need to solve for is this x right here. So because that's the only one, we can simply use the tools that we know to get rid of everything else and get that x by itself. So basically when you're solving, you need to use the opposite of the order of operations. So instead of adding or subtracting last, that's what we're going to get rid of first. So we're going to add 5 to both sides of the equal sign, I should say. 13 plus 5 is 18. And what we're left with is this 2x squared. Next thing we need to do is get rid of that 2, because this is 2x squared. That's 2 times x squared, so we divide both sides by 2. We're left with 9 equals x squared. To undo a square, we need to square root. Square root both sides, we end up with x. Square root of 9 is 3, but it's also negative 3, because negative 3 times negative 3 is the same as negative 3 squared. Well, that is ugly. Hang on. Which equals a positive 9 as well. So the square root of 9, when we come over here, the square root of 9 is also negative 3 as well as positive 3. So anytime you take the square root, generally you're going to have more than one answer. Okay, so now in this situation, we have a different case, because we have both an x squared and an x. Those are not like terms, so we can't combine them. It also makes that a lot harder to isolate them. So in this case, we have the square root, the quadratic formula to solve this. So when we have, playing with this. When we have a square root, or a quadratic, with both an x and an x squared, a is the number in front of x squared, b is the number in front of x, and c is the number that is by itself. So in this case, a equals 2, because of that number right there. B equals 11, that number right there, and C equals 25. In this case, both of these, that's supposed to be 25? No, that's supposed to be 15. In this case, give me just a moment to fix that. There we go, my bad. So in this case, all of these happen to be positive, but sometimes these might be negatives in between them, so you need to make sure those negatives stay attached to the number. So then what I need to do is take my quadratic formula and plug everything in. The negative is part of this formula, so make sure that negative stays there. And then I plug in my value of 11 for b, plus or minus square root of 11 squared minus 4 times 2 for a, and 15 for c. All divided by 2 times a, so a is 2. Let me erase again. 2 times 2. And then I go about simplifying. So it's still x equals negative 11 plus or minus the square root. 11 squared is 121. 4 times 2 is 8, times 15 is 120. All divided by 2 times 2, which is 4. Simplify some more. Negative 11 plus or minus square root of 1, all divided by 4. Just so happens 1 times 1 equals 1, so this is negative 11 plus or minus 1, because I took the square root of 1 from here to here, all divided by 4. Now that I'm completely simplified, I need to split this off into a plus. So I do negative 11 plus 1 divided by 4, which is negative 10 divided by 4, which is negative 2.5, so negative 2.5. You could have also left that as a fraction, and that would have been perfectly acceptable. And then I also do the minus negative 11 minus 1 divided by 4, which is negative 12 divided by 4, which equals negative 3. So I've got my two answers here, which you generally are going to have, not every time, but often with a quadratic formula. Next up, we need to be able to graph these quadratics using x and y intercepts. Remember that this is your x-axis, and all along that x-axis, y equals 0. This is your y-axis, and all along the y-axis, x equals 0. We're going to use that information to find our x and y intercepts. So if I'm looking at my y-intercepts, I'm going to plug x or 0 in for x. So for my y-intercept, I take my original equation, y equals, and instead of the x's, I simply put in 0. 0 squared minus 2 times 0 minus 8. 0 squared is 0. Negative 2 times 0 is also 0, so I'm left with y equals negative 8. And I put that on my graph. That's the point 0, negative 8. Right there. That is my y-intercept. Next up is my x-intercepts. So my x-intercepts is a slightly more complicated process. Not complicated necessarily, but lengthier certainly. I put in 0 for y, and then I need to solve for x. And just like in the last problem we did, I need to use either factoring with zero product property or the quadratic formula. So I'm going to use the quadratic formula, x equals negative 2, so negative b plus or minus square root negative 2 squared. Notice the parentheses, that's important, times 4 times 1 times negative 8. All divided by 2 times 1. Simplify that to a positive 2. That's where the parentheses are important when we have double negatives. And then 2 squared, negative 2 squared is positive 4. That's also why the parentheses are important. And then 4 times 1 times negative 8, negative 4 times 1 times negative 8 is a positive 32, all divided by 2. So that is 2 plus or minus the square root of 36 divided by 2 equals 2 plus or minus 6, all divided by 2, and that's where I split it. Sorry for the jumble down here. 2 plus 6 divided by 2 is 8 divided by 2, which is 4. So one of my x-intercepts is right here at 4. And the other one is 2 minus 6 divided by 2, running out of space, negative 4 divided by 2, which is negative 2. So that's my other y-intercept right there. So I'm going to go ahead and erase this stuff. That's my x-intercepts using the quadratic formula, and y-intercepts, or y-intercept singular using a much simpler process. So then the last thing I need to do is find my vertex. My vertex is the lowest or highest point on the graph. Vertex is found by the formula x equals negative b over 2a. So x equals negative 2 divided by 2 times 1, which is a positive 2 divided by 2, which is 1. So that means my x value is 1. My y value I need to find by plugging back into my original equation. So I have y equals 1 squared minus 2 times 1 minus 8. 1 squared is 1. Negative 2 times 1 is negative 2 minus 8. 1 minus 2 is negative 1 minus 8 is negative 9. So my vertex is the point 1, negative 9, which I find right here. And then I'm just going to, after I've specified those 4 points, I'm going to make my parabola shape best that I can with my squiggly pencil. And that is graphing a quadratic. Next is function notation. There are 2 different ways to use this. Make sure you remember that this f of x is not f times x, it's just called f of x. It's another way of saying y. They're essentially the same thing. And so if I have find f of 3, that's like saying what is y when x equals 3. So if I look at this 3 that's in place of the x, I'm also going to put it in for that x right there. So when I solve this, anyway, sorry about that. When I solve this, this is f of 3 equals 2 times 3 instead of x minus 8. And then I just need to evaluate. 6 minus 8 equals negative 2. And that's my answer for that one. On the other hand, when I'm solving when f of x equals 12, I don't have a value for x. I have the value for f of x. So I'm going to take this 12 and I'm going to put it in for f of x. So this is like asking solve for x when when y equals 12. So then it's going to be 12 equals 2x minus 8. Add 8 to both sides. So 20 equals 2x. Divide by 2. So I have x equals 10. So that's function notation and the 2 kinds of things you're going to need to do with function notation. It's not actually solving. Whoops. The other thing you need to know about functions is whether or not whether or not something is a function. And the way you can determine that is there only one y value for any given x value? So with a graph, when I have a graph, that's the vertical line test. If I draw a line anywhere on the graph, does it only cross through my graph one time? And in all of these, it's just that one time. It doesn't cross through it twice. So, yes, this one is a function. There is only one y value per x value. And then if we look at part B, we're looking at our x values. So we've got an x value of 3, 4, and then 3 happens again. And what you'll notice is that we've got 2 different y values for the same x value of 3. So because of that, because we have 2 different y values, this is not a function. Because we have 2 y values for the x value of 3. And that's it. That's what you need to be ready for on your test. Make sure you take the time to prepare thoroughly, and good luck. We'll see you next time.